So yes, welcome to my YouTube channel friends. My name is Amandeep Singh. So इस lecture में हम start करेंगे question of the days. So in this video we will do two questions. Okay. So the first one is how many zeros does the function fx e raised to power x minus 3x square have in R? Okay. So option A is 0 and option B is 1. Option 2 C is 2. Option D is none of these. Okay. So if you know about the graph of Ex and 3x square, so this will be really helpful for you because to solve this question, because we know if x is 0 of fx, uh, then fx is equal to 0. Means if x is any zero of a function of any function f, like when we put the value of x in such function, then definitely the answer will be 0. So for this ex minus 3x square is equal to 0. So for this ex is equal to 3x square. Okay, so this result will be fine. So now for this we can say we have to check from it how many points the graph of ex and 3x square are intersect. Okay, uh, we can check from it how many points the graph of ex and 3x square are intersect. Okay, so if graph of ex and 3x square are intersect, suppose it intersect one point, then we can say the zero of this function are 1. So if this intersect two or more points, then we can say that zero of the function are 2 or more. So for it, you have to know the graph of e raised to power x. The graph of e raised to power x is like it, because when we put e is equal to 0, then answer is 1. So therefore here 1. Okay, so when we put any negative value, so e raised to power x cannot be negative. This means 1 upon e, then 1 upon e raised e, the value of e exponential function is 2.71 something. Okay, so it will be 0 point something. So the graph are like it. Okay, so the graph of ex square is this. So now for 3x square graph are like it. Okay, so we can say that the function has at least two zeros. The function has at least two zeros. I used at least word because I can't say about this graph exactly, because the graph of e raised to power x are also move on this sides, like matlab, are also move on this sides. Means I can say the graph of 3x square are also like that type. Okay, then e raised to power x are also like that type. So I can't say exactly. Okay, so therefore these two options are discarded directly, because this function has at least two zeros. Okay, so now for this graph we can discard two options. Okay, now we have to check by other method. Okay, graph helps to discard the option. Okay, now we have to check another method for solving this. For this, uh, again we write fx is equal to x square minus, sorry, e raised to power x minus 3x square. If we put like f is equal to -1, then the value of this function is e raised to power -1, 3 minus 1 to the whole square, 1 upon e minus 3. Means that actually 1 upon e is 0 point something, means this value is less than 0. Okay, so now when we put f is equal to 1, so the function will be or like f is equal to 0, the function will be e raised to power 0 minus 3 0 to the whole square. Means e raised to power 0 means 1, it is 0, so 1 is greater than 0. Okay, so when we put f raised to power f is equal x is equal to 1 here, so it means e raised to power 1 minus 3 1 to the whole square. So e raised to power 1 is 2.718 something, so it means 3. So definitely answer are in negative, so value is less than 0. Or when we put any number like 10, 11, 12, we put any number, so it will be e raised to power 10 minus 3 tenths to the whole square. So the value of e is 2.718 to the power 10 minus 10 to the whole square is 100 into 3, it is 300. Okay. So when we solve it, we can guess like if 2 raised to power if 2 raised to power 8 is 512. Okay. If we doing 2 raised to power 9, if we do 2 raised to power 9, then it becomes 1052, I think. 1032, yes. Okay. 1024. Yes, I think. So definitely we can easily see the value of 2 raised to power 8 are greater than it. Okay. Here 2.718 raised to power 10. So definitely it will be positive. It will be positive means greater than 0. Now if we observe these values, we can say like here -1, here we put 0, 1 and 10. If we put if we use the value -1, then the value will be negative. For f is equal to -1, the value will be negative like it. Okay. Now when we put f is equal to 0, the value will be positive. Okay. So means like it. Okay. So when we put f is equal to 1, the value will be negative like it. And when we put f is equal to 10, the value will be positive like it. So now for this curve, we can say 0 means the points which intersect at x-axis exactly when we see. Okay, so how many points? Uh, how many points from which curve intersect x-axis? Let us see here. 1, 2, and 3 means a curve has at least 3 zeros. Okay, we can't say about another zeros, means exactly 3. We can't say about exactly 3, but we can say that it is at least 3. So therefore, option C can also be discarded. So for this, our answer is option D. So I hope you got it. Okay. So now we will do next question. Okay. For this question, f from 0 to infinity to r be defined as a function fx sine sine of the angle x cube upon x. X is not angle, upon x is not angle, it is denominator. X cube are angle of sine. Okay. So then f is option A is bounded and uniformly continuous. Bounded but not UC. UC means uniformly continuous. Option C not bounded and not UC. Option D is not bounded but UC. Okay. So we have done in previous lecture of uniform continuous. There are we have discussed there are three results of to check uniform continuous. Means three shortcut we can say. For first one for AB, if AB is bounded, means AB like for bounded interval, we can say for bounded interval. Okay, bounded interval means interval can neither be negative. Okay, bounded and open interval we can say, and open. For this, okay, for this we should only check. For this we should only check the limit. Okay, the limit x approaches to A and limit x approaches to B. If function is finite by putting this value, so this function is this fx is uniformly continuous. We can say. Okay, so now for this the open interval are infinite. Now for this the open interval are infinite. Okay, so for this value, okay, for this value we should check the derivative. We should check the derivative because it is third case. Third case. Because in previous uniformly continuous lecture, we study uniformly continuous concept case wise. Okay. So if closed interval, this is first and it is second case, and this will be third case. Okay. So for this we have to check f dash x, means derivative of particular function. If derivative of particular function is bounded by put the two end values, by putting the two end values, means 0 to 0 or infinity, so then we can say that this function is uniformly continuous. Okay. We have to first find the derivative. If derivative is bounded by put the value of end point of the interval, particular interval, then we can say that this function is UC. This result are applied for open interval, and interval is unbounded, means infinity are produced on this interval. Okay. So okay, we can check for A option. First of all, fx is equal to sin x cube and x. Okay, so the value of 0 and infinity. Now first we should check bounded. Is it bounded or not? Okay, for bounded, we should check the endpoints. If the value of function in at an endpoint are finite, then we can say the value of function is bounded, or the function is bounded. Okay, so we should check at endpoint. Okay, clearly the value of sine for any theta, for any angle are lie between -1 to 1, means clearly it is bounded. It is bounded. Okay, it is bounded. So when we put x approaches to infinity, so it will be f. We can say that infinity. So it will like this term are bounded, this upper portion are bounded. So now we put x, when x approaches to infinity in a denominator, so it will be 0. So clearly at infinity there will be no problem. Okay. So when we discuss about x is equal to 0, so for this we can use one result, limit x approaches to 0, sin x upon x is equal to 1. Okay, for this we use this result. We will use this result. So therefore, limit x approaches to 0, fx, limit x approaches to 0, sin x cube. So for this, we have to make x cube on denominator. Okay. So for this, we have to multiply and divide by x square. Okay. So it will be x cube. This value will be 1. This whole value will be 1 because we put limit x approaches to 0. This is 1. When we put x is equal to 0 on this function, then it will be 0. So definitely function is bounded on a particular interval. So bounded to definitely true hoga. So therefore option C and option D are directly discard. Okay. Now we talk about option A and B. So clearly we have to check is it uniformly continuous or not. For this we will already discuss how can we check. Okay. So first of all we have to find derivative by third case. So when we derivative this particular function, so it will be cos x cube. We have to apply u upon v rule. X square x cos x cube into 3x square. Okay, it will be a sin x cube into derivative of x is 1. Okay, so now it will be 3x cube cos x cube. Here the value is 3x cube and x cube minus sin x cube upon x square. Okay, now okay, if we put x approaches to 0 here, so this will be 0 by 0 method, है ना? This will be 0 by 0 method. If we put x approaches to infinity here, uh, then we can say first we should divide. Okay, so this will be 3x square 3x cos x cube minus sin x cube upon x square. Okay, so yes. Okay, so if we put first infinity here, then it will be this term will be 0 because sign is bounded clearly. This term will be 0 when we check at infinity. Okay, now we have to check is it bounded or not. Okay, so for at an endpoint, first of all, we have to check at infinity. So now we check about this term. Is it bounded or not? Okay, it will be 0. Now we have to check for this term. So this will be, first of all, we have to check at infinity. Okay, now. So it will be infinity into 0, infinity into not say exactly 0. Okay. So yes, 3x into cos x cube. It will be any term. Okay. So exactly, we can say it is not exist. Wait. So okay. If we directly put limit here, if we directly put limit here, then this function will be, if we directly put limit x approaches to 0 here, then function will be, uh, we can say function is uh, bounded, or function is exist. Okay. So yes, so for this we can say the uniform function is uniformly continuous. Okay. So because otherwise it's quite tough. So okay, so you should note one thing, you should note one result. If if for open interval, if for open interval limit are not exist at a and b, means at end point, and open interval are unbounded, so then we use third step. Third step means then we use third case, means f dash x. Okay. So otherwise we have to use such case if limit is exist for particular value. Okay. So in such case, limit is exist for limit x approaches to 0 and x approaches to infinity, because we have to check for bounded it. We have to check for bounded. है ना? When we put limit x approaches to infinity, it is 0, and when we put 0, it is 0. So definitely it is also uniformly continuous. So we can say as such type. Okay, so option A is true and option B is discarded. So thank you.